Hey guys, so today we're going to talk about balancing chemical equations, something we've been practicing for a while, but I feel like we needed a quick review, so I wanted to go over a few problems with you kind of from the beginning. So here we go. First one, we take potassium and add chlorine, and you get potassium chloride. So what I tell people if they're starting out and they kind of don't know what to do at all is to go ahead and put a line underneath the reaction arrow and go ahead and total up how many of each element, how many atoms of each element you have on either side of the equation. So in this case, we have K and Cl involved. On the left side, you have 1K. On the right side, you have 1. On the left side, you have 2 Cl. And on the right side, you only have 1. Okay? So from the first part, we already see that our Cl's do not match. So what I'm going to go ahead and do is put a 2 in front of KCl. Why? Because that acts kind of like the distributive property in math, where that 2 is going to distribute throughout that molecule. So we're actually going to have 2 molar KCl, or 2 moles of KCl, excuse me. And what we'll actually do is change this to a 2 because there are 2 potassiums now appearing and 2 Cl's. So now, if something matches up, I'll go ahead and put a check mark, so Cl is good. But if we see potassium no longer matches up, so what can I do to fix that problem? Well, I can just multiply our potassium by 2 and put a 2 in front. And now at this point, you should have the same number of everything on either side, and you're good to go. Next, nitrogen gas plus hydrogen gas makes ammonia. So let's make our chart as we did before. Soon you won't have to do this once you kind of get the hang of it, but it's good to use starting out especially. I'll have 2 N's on the left, 1 on the right, 2 H's on the left, and 3 on the right. Okay, I'm going to start with H. Why? If you ever end up with 2 of something on the left and 3 of something on the right, you should find the least common multiple, which is 6. So what I'm going to go ahead and do is I tell people to take the numbers and switch them and put them in front. What does that mean? I have 3 H2 and 2 NH3. That should change. Now on the left side we have 3 times 2, which gives us 6 H's. And on the right side here we have 2 times NH3, which gives us 6 H's as well. And then if we look, it has also changed the amount of nitrogen we have. That becomes a 2. So in doing that switching that we showed at the beginning, that has matched up both N and H, and we are completely balanced. I don't know if I mentioned this before, but if ever anything is blank, you can either leave it as a blank or you can put a 1 in it, whatever you most enjoy. All right, so this is a longer one, and sometimes these ones can actually be incredibly easy. When does that happen? When they have polyatomic ions. So if you look, phosphate appears on both sides, as does hydroxide, which is good. So what we're going to do, I actually, instead of totaling up all of the oxygens, I'm going to keep the oxygens separate in their ion. So I'm going to have an Na, we'll have a PO4, we'll have a K, and we'll have an OH. All right? And if we look, on the left side we have 3 Na, on the right we only have 1. On the left we have only 1 PO4. Don't get confused. That 4 is only saying 4 oxygens, but the PO4 total means that it's phosphate, which is an ion. On the right we also have 1 PO4, so our phosphates are matched up. So we may not want to mess with that. Potassium, we have 1 on the left, 3 on the right, and hydroxide we have 1 of each, which means it's currently balanced. Okay, so if we notice, Na and K are our 2 issues. So let's look. Let's deal with Na first. If we see on the left side of this, right here, we have 3 NAs. We only have 1 here. So I will put a 3 in front, which makes me have 3 NAs. That's great. I'm going to also do the same thing with K. If you notice on the right, you've got a 3 for K3 right there. So we'll take that 3 and put it in front on the left. That should make K match up. Now what have we forgotten to do so far? Deal with hydroxide, that OH. So if we look on the left, you should have 3 times 1, which gives you 3 hydroxide there. And on the right, you should also have 3 times 1, which gives you 3 hydroxide there. Okay? So now you're fully balanced. Again, you can put 1s here. So the coefficients across would read 1, 3, 3, 1. Okay. Here is another one. You're going to have silver nitrate and copper. Becomes copper to nitrate and silver. So you see silver. Rather than splitting up N and O, since it's nitrate and since it appears on both sides, I'm going to keep it as NO3 and copper. So if we look, there's 1 silver on either side, there's 1 copper on either side, and our only issue is that there's 2 nitrates here and only 1 there. In order to solve that, we know that we take the 2 and make that what we put in front as the coefficient on the other side. So you get 2 silver nitrate. That changes our nitrate on the left to be 2, changes our silver on the left to also be 2. Now what no longer matches up? Our silver on the right. To fix that problem, you put a 2 in front, and then you're done. And our last one for today. So as we look, let's identify ions. Sulfate appears on either side, so I'm going to leave that alone. I have Al, I have Br, I have K, and I have SO4. I'm going to keep that by itself. It just makes it easier rather than splitting up the S and the O into separate groupings. So if we look, I have 1 aluminum on the left, 2 on the right, 3 bromines on the left, 1 on the right, 2 potassium, 1, and then we only have 1 sulfate here in this box on the left, and we have 3 on the right. And that comes from this 3. Okay? So now, I like to deal with the big polyatomics first. That just makes it a lot easier. So in order to do that, I'm going to have to multiply 1 by 3. So I'm going to put a 3 in front. That's going to give me the 3 sulfates that I want. Because remember, I can't really change how they're bound to each other because I need the charges to balance. So if I want the amounts on either side to balance, I have to change the coefficients, which is why we did that. So what does that do to the left? Well, it also makes me have 6 potassium because it's 3 times 2. So now that I know I have 6 potassium, we have another issue. Our potassium does not match up at all. So in order for 1 on the left to change, or on the right to change, I'm going to put a 6 in front of it. So 1 times 6 equals 6, which means potassium and sulfate are now happy. However, bromine is not. Bromine is 3 on the left, 6 on the right. In order to fix that, I'm going to multiply 2 by all of AlBr. That makes 6 bromines and actually solves our aluminum problem. So then we only have 2, which makes it all match up. I hope that helped. Watch it again. Try and make sure that you can do it all without me, and you'll be good to go. Have a good one, and we'll talk